Hello everyone, welcome to my channel Mathenthusiasm. This video is day 14 of the 30-day challenge. It is all about integration by parts. Let's check it out. Integrate x times arc cosine x dx. First of all, we have to decide which term to be absorbed into the differential. Because x is algebraic function a, arc cosine x is inverse trigonometric function I. By the last rule, I is in front of a. So I is u and a is dv. In other words, we have to absorb x, that is to integrate it. So the integral is equal to 1 over 2 times integrate arc cosine x d bracket x squared. Comparing with the formula of integration by parts, u is equal to arc cosine x and v is equal to x squared. So the first term is the product x squared times arc cosine x. The second term is the integral by swapping u and v, which is integrate x squared d bracket arc cosine x. Let's look at the differential. Because the arc cosine x dx is equal to negative 1 over the square root of 1 minus x squared, therefore the bracket arc cosine x is equal to negative 1 over square root of 1 minus x squared dx. If you have watched the video of day 13, you may realize that the derivative of arc sine x is equal to 1 over the square root of 1 minus x squared. Comparing these two results, they differ by a negative sign. You may wonder why it is the case. Let me know in the comment section. I shall make a detailed video about all important properties of inverse trigonometric functions. Come back to the question. Let's put this result into the step. Therefore, the integral becomes integrate x squared over the square root of 1 minus x squared dx. Here you can see that the sign is changed from negative to positive. It is because we have the extra negative sign in the differential, the bracket arc cosine x. Now let's focus on this integral in purple box. Because the denominator is square root of 1 minus x squared, so we apply the classic trigonometric substitution. Let x is equal to sine theta. Differentiated, we get dx is equal to cosine theta d theta. We can simplify the denominator. Square root of 1 minus x squared is equal to the square root of 1 minus sine squared theta, which is equal to cosine theta. Let's put everything into the integral. For the integrand, x squared over square root of 1 minus x squared, it is changed to sine squared theta over cosine theta. And for the differential dx, it is equal to cosine theta d theta. We can cancel out the term cosine theta. Therefore, the integral is equal to integrate sine squared theta d theta. To evaluate this, we need to use the double angle formula. Because cosine 2 theta is equal to 1 minus 2 sine squared theta, rearrange the terms, we get sine squared theta is equal to 1 over 2 times bracket 1 minus cosine 2 theta. Let's put this result into the step like this. Then it is easy to integrate, which is equal to 1 over 2 times bracket theta minus 1 over 2 sine 2 theta plus c. But it's not the answer yet, because the original integral is in variable x instead of theta. We have to express this in terms of x only. We can do so for the first term. From the substitution, theta is equal to arc sine x. However, it is not that straightforward for the second term, because we have 2 theta. If we write sine 2 theta is equal to sine bracket 2 arc sine x, it doesn't look very nice. What should we do? Well, we can use double angle formula for the second time. Sine 2 theta is equal to 2 sine theta cosine theta. Then we can change from 2 theta to 1 theta only. it would be easier to express the answer in terms of x. You shall see that in a second. Let's put this into the expression like this. Cancel out the 2, then we have 1 over 2 times bracket theta minus sine theta times cosine theta plus c. Remember that in the previous steps, we have x is equal to sine theta. We can put this into the first two terms. Also, square root of 1 minus x squared is equal to cosine theta. This is for the last term. Great! Let's put everything inside. So this integral is equal to 1 over 2 times bracket arc sine x minus x times the square root of 1 minus x squared plus c. We are almost done. Go back to this slide. Our original integral, integrate x times arc cosine x dx, is equal to 1 over 2 times bracket x squared times arc cosine x plus this integral in the purple box. We put the result into the expression like this. Now, we can take out this 1 over 2. Therefore, we get the final answer, which is equal to 1 over 4 times bracket 2x squared arc cosine x plus arc sine x minus x times square root of 1 minus x squared plus c. Wow, we have solved a really complicated integral. Let's check out some more interesting questions with a mix of different techniques. See the link of the video on day 15.